Good afternoon to all from the editorial board of BuildUp Portal. For the ones who are attending a BuildUp webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. Just a brief explanation of what is BuildUp. BuildUp is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community, and you can also upload news, events, present a case study, results from a project, and so on. I would like to invite you all to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. At the end of this webinar, the link to the full presentations and the file to the PDF presentation will be made available in this section of the portal. It is a pleasure to host today's fourth webinar of the EPB Standards series entitled EPB Standards Hourly versus Monthly Method, which is organized in collaboration with the EPB Center and REVA, the Federation of European Heating, Ventilation and Air Conditioning Associations. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end, after the presentations. Now, I would like to present the agenda of today's webinar and introduce the three speakers. Jaap Hogeling, Chairperson, CNTC 371, Energy Performance of Buildings Project Group and European Committee for Standardization, will start the presentation by giving an introduction and overview of current European practices. Then Dick van Dijk, EPB experts from EPB Center, will get into more detail about the monthly versus hourly calculation method, considering energy needs and indoor temperatures. Finally, Laurent Sokal, independent EPB expert, will continue the discussion about the calculation method and technical systems. As you can see from the screen, we have scheduled a series of webinars on the topic of EPB standards. Take a note about the next webinar, which will take place on the 16th of June at 12, and which is entitled EPB Standards Linked to Health and Well-being. Now, I would like to leave the floor to Jaap Hogeling. So please, Jaap, we can start the session.
Yeah, thank you, Julia, for your nice introduction. My presentation is about the introduction and overview of the current practices in Europe as far as we know, and I will explain later why we don't know everything. My background is, as said, the chairperson of this CNTC, who coordinated the work on the mandated standards that were produced the last 5 years and published in 2017, 2018. And I participate in SEN and ISO work on energy performance in buildings, and I'm active in ISO, the Dutch organization, on building research, and initiator of the EPB Center, which is an initiative of the Dutch organization and REVA. The background is always the standards that have been developed under the mandate 480. The set of standards you perhaps well know after also participating in earlier webinars. And we have to keep in mind that the set of standards shall be systematic, clear, comprehensive, benefit professionals and member states, and have a continuous but modular overall structure enabling step-by-step implementation by member states, and a balance between accuracy and level of detail, being flexible but harmonized with national choices. And that was also addressed in earlier webinars where we explained the approach in the annexes AB. Follow a holistic approach as a key driver for technical innovation and change. Then, of course, it was the EPBD of 2018 where in the Annex 1 there is a requirement for more transparency and better data, and a new obligation to describe the national calculation methodology following the national annexes of the overarching standards. And in this Annex 1, it is clearly said that member states shall describe their national calculation methodology following the national annexes of the overarching standards. And this provision shall not constitute a legal codification of those standards. So saying, okay, of course, it is the best to use these standards, but you are not obliged to use them. And if you have a national procedure, you have to show on basis of the annexes of these standards how this procedure is working. The transposition date in the annex of the EPD or in EPD is the 10th of March of this year. So member states shall bring in force and report to the Commission about their provisions. These are the overarching standards. Just to remind you, the general framework and procedures in Vision 2000-1, the indicators for ratings and certification requirements, the external climate conditions of Part 10, and in Vision 2016, the core standards for the energy needs for heating and cooling and internal temperature sensible and latent heat loads, the calculation procedures, and in Part 18, the indicators for partial EPB requirements. What about this date of 10 March? Did all member states report? Of course, I don't know. The Commission at this moment has not the freedom to disclose all this information. They even have to analyze the information they received because due to the COVID crisis, there is some ongoing actions from many member states. We know from several member states that they reported accordingly this requirement, like Estonia and Germany, and several more member states from which we expect, like Italy, France, Netherlands, Romania, Croatia. But we don't know yet for sure. But we also know that there are countries in Europe, like Switzerland, that are not obliged to report. However, they will implement the SENS standards. We are also aware that many countries are now in the process, and due to the fact that due to the COVID crisis, the Concerted Action 5 seminars in March had to be cancelled. We also received limited information about their progress and planning. So my presentation is more based on what we knew a few months ago, but we are still collecting information. If you talk about plans and implementation of the standards in the different countries, you have first to distinguish between the requirements in Annex 1, where you have to refer to these overarching standards. These 5 overarching standards, and the feedback from some member states is that it is not easy for the current methods always to specify this according to the annexes of those overarching standards because of the huge deviations between the procedures. To help member states, we developed a guide, an example, available at the EPB Center website to see how you could do that. But looking at the future, and bringing national methods more in line with the total set of EPD standards, which is asked by the industry. They want to have a level playing fields for the different services and technologies throughout Europe, and are well, you could say sometimes frustrated that a certain technology is awarded in a different way when they pass a boundary of countries in Europe. It will be more efficient in Europe if we have one system, and it makes comparison between status reports more transparent. But it takes time, especially if the national methods has recently already been revised. In many countries, the building industry is not too happy to revise procedures. That is understandable, and normally they expect that building laws will stay at least for several years, 5 years or something like that. And so if they just have a new procedure, they need more years to develop. And then, of course, the need for new tools that are necessary if you have a new procedure in the legislation. So where are we? Some countries adopt almost all the standards, fill in the national annexes, and are preparing proposals for improvement of the standards. Well, if they find some questions around or perhaps difficulties in use of certain standards, they can report it to the EPB center, so we can try to resolve that. These typical examples are Italy and Croatia, who did that. Some countries copy, translate most of the content of the standards into national methods, like the Netherlands, ranging some standards for, let's say, 60%, some standards almost for 100%. And Germany also included in the national procedure most of the standards, and ranging also from 60 to 90%, and some 100% taken over in the national procedure. And some countries copy elements of the content of standards into the national method. And then the choice between hourly and monthly methods that will be addressed by the other speakers in this webinar. Well, we see that countries like France and Spain often use hourly procedures for non-residential. Several countries intend to change over to hourly, as will be explained also later this morning. And several countries discussed to change over, but didn't make a decision yet. So in one example, I know from several German experts that they expect to do this the next revision round, which will be in the coming years. Many countries express the need for a common core software if they want to change to hourly procedures. Well, what about the situation in different countries? I will illustrate it on the basis of a presentation that is made earlier in the ISO meeting and based on slides prepared by Laurent Sokal, the other speaker in this webinar, and an article that is also published in the RIVA journal in October last year. Well, this is a picture that is not only valid, you could say, for Italy, but also for other countries, where you see in the 70s we just sorry we looked at the heating systems, and slowly in the 90s we paid more attention on energy also, and also on the comfort of buildings, the heating and cooling, domestic hot water, and dehumidification, and other aspects. But still in a simplified way with monthly calculation procedures. And now today we are in Italy also at the decision that is made towards hourly, and that will be explained also later in this webinar, and that is expected in the near future. And what is the rationale behind this? Well, a country like Italy, but has a great variety of climates, from cold to warm, and also a great variety in technical systems. And the current standards, as in many other European countries, for ventilation and cooling are very basic, or monthly procedure, and they need to be more flexible. And the monthly procedure is considered not suitable for the cooling needs in a climate like in Italy, and a minimum of dynamics of the building envelope has been taken in account. Dynamics are also relevant for technical systems, especially in high performance buildings where the effect of controls have to be taken in account properly. And standard conditions of use should be representative. It means that monthly conditions of use are not very intelligent, and this doesn't describe the intermittent use of the buildings in a proper way. And the current set of standards is more than 10 years old, so it should be updated. And updating means that the step calculation time step should be hourly, and as the standards are, of course, required for legal purposes, it should be traceable and reproducible. And to do so, you also need professional training. You need to develop tools to apply the new EPB standards in a proper way. And using, for example, the 50/2016 means that the description of the building doesn't change, and the calculation procedure is because the calculation procedure is fully detailed. So the basic process in Italy, and you can also compare it in other countries. You see a similar process, adopting the standards for hourly, working groups that work in a country to decide on the links between the standards, complementary information like the user patterns, the time intervals. And also when you talk about hourly procedures, you need a reference year for different regions in your country, but you have to agree when the year starts, because otherwise you cannot you can get surprising outcomes because of the weekend and the weekend days that could be on different days. More than at this moment in Italy, more than 2/3 of the national annexes are ready for inquiry, and they are actively interacting with the EPD Center and Sensor Project to share experience on this issue. So we welcome also other countries to do so. Some national modules are being developed as well in the frame of the EPD Standards modular structure, which will also be communicated with the different TCs. And when this work will be finished, well, last year we expected it will be by the end of this year, but due to the COVID crisis and some policy issues, we expect it will be a little bit later. An example for Switzerland. Switzerland is not obliged to report, but they want to use the standards, and there you see this similar picture, heated only buildings in the past focused where they used the 3790 from 2008 on monthly procedure, and towards conditioned buildings hourly procedures using the 2016, where the room and other hourly methods will be included and connected as well. They expect to complete this work in 2020-22. That is, you could say, a similar picture for many other countries. For France, it's a situation also where they used the simple hourly procedures from the 3719 2008 and partial national methods. And the next French regulation, which is still under discussion, will bring a new software update for the package they use in France for the energy performance calculations on hourly base, and then the energy needs based on the 2016, and also the systems as far as possible hourly, and they expect this big update in 3 to 5 years. In Croatia, you see a simple situation, a similar situation, where the old standards were used in 2008, and now they use the current set on monthly procedure, but they want to use them on hourly procedures, especially when you focus on the NSAP calculations, where you need more accuracy and sensitivity. This will be implemented in regulation as soon as an appropriate Fahrenheit calculation tool is available on the market. And that is an issue that a statement that we received from more countries in Europe, especially the smaller countries. And their Ministry of Construction is in favor to develop a common open European source kernel, and they don't want to finance any other new calculation tools as they did in the past based on the new EPB standards, because they consider this as a task for Europe and something that should be a common source kernel. And this is a message we received from many other countries in Europe. Well, we can only report this on this webinar. Well, you can read more about these implementations and backgrounds and situations in those countries. We published it in the Riva journal. And if you have any other questions, I am here to answer them. Thank you very much.
Good day, everyone. My name is Dick van Dijk, and I will give a presentation on the energy need and indoor temperature calculation, whether hourly or monthly method could be chosen. So a little bit of my background here, just for the record. If you are interested, you can look it up in the recording of this webinar afterwards. So I will not spend more time on this now. As Jaap explained, we have the set of EPB standards. It consists of about 50 documents. But not all these documents are relevant or for the calculation of the energy performance of the buildings. There are 5 most important standards. Starting here, you have the boundary conditions, outdoor, indoor, component and product characteristics. So there are standards on these issues. One of these standards is the EN ISO 52010 Part 1 on conversion of climatic conditions for the energy calculations. Then at the next level, you calculate the energy needs, and for that we have the standard EN ISO 52016 Part 1, the energy needs for heating and cooling and indoor temperature calculation, and that's the subject of my presentation. And at the next level, you have several standards dealing with the energy use. So for heating, cooling, ventilation, domestic hot water, lighting, and including also the impact of building automation and controls. And then at the top, you have the overarching standard, the EN ISO 52000 Part 1, for the aggregation of all the energy uses from the different systems and to convert it to primary energy or other indicators. And I should also say that this overarching standard also covers the complete framework, like the common terms, modular structure, and so on. And then here to the right, you see two standards which are quite specific because they are kind of post-processing to convert the calculated energy and into the overall indicators, requirements, and ratings on the overall level, and this one on the partial level, in this case, the building fabric and the energy needs. So just to remind you of what Jaap also already mentioned, and which was the topic of a previous webinar, the set of standards is harmonized, but there are also clearly identified options and national data that have to be chosen and can be chosen at the national or regional level. And one of the main choices is the time interval for the calculation of the energy performance, and that's why I show it here. If we look at the path from the yearly to hourly calculations, we can read in the overarching standard that in principle different time steps, time intervals are allowed for the calculation. You could choose an hourly interval, monthly time interval, seasonal, a yearly, or a bin. A bin is a very special method. So in this presentation, we focus on the mostly used time intervals for the calculation, the hourly calculation or the monthly calculation. Well, sometimes there's a confusion. If we choose for an hourly calculation method, do we need to choose an hourly calculation step for each EPB standard? Well, that's not the case. For instance, if you take a simple example like a thermal resistance of a building component, usually you have a fixed annual value for that, and there are more examples like some components in systems can be well described with a fixed annual value. But the holistic approach means that the system performance is part of the overall energy performance calculation. So there are dynamic interactions between the energy needs, the indoor temperature, and the system performance. And these dynamic interactions often require an hourly calculation in different elements of the whole set of standards. So where you have dynamic interactions, you need to choose hourly calculations if you go for the hourly calculation method in general. So why would you choose for an hourly calculation? Well, that's because many technologies, in particular for low energy buildings, they show hourly and daily variations with weather and operation and strong and dynamic interactions. For instance, solar blinds, temperature settings, the energy needs, the occupation, accumulation of heat, mechanical ventilation, ventilative cooling, weekend operation. These are all dynamic elements and they all interact in a quite complex way. So, and they have a strong effect on the heating and cooling calculation. And the limitations of the monthly method in this respect is that the monthly method can only deal with monthly mean values, and it has to build in corrections, correlation factors to take into account all these dynamic effects. And this is illustrated in a very simplified way. For instance, for an office building with which is unoccupied in the weekends, you would typically see internal gains during the weekdays and much lower ones during the weekend. But if you have a monthly calculation method, you would only be able to take into account the mean value of this. The same goes for mechanical ventilation. Also, for the operation of the solar blinds will clearly be different depending on how the controls are set, but they will be different during occupation and during non-occupation. And then again, the monthly method just has to deal with some mean value of this. And the same for cooling set point, or if you take into account free cooling by extra ventilation. So the monthly method knows only the monthly mean value, while you see these patterns are quite complex and not very synchronous. So looking at the main scheme again of the standards, so the energy needs and the indoor temperature are the focus for my presentation, and that is because this is the core standard for the choice between a monthly or hourly calculation method. So let me describe briefly what the ISO 52016 Part 1 is about. So the title is Energy Performance of Buildings, Energy Needs for Heating and Cooling, Internal Temperatures, and Sensible and Latent Heat Load. Part 1, Calculation Procedures, because as for each EPB standard, there's also a Part 2, which contains a technical report with more explanation and examples. So this standard replaced the well-known EN ISO 13790 from 2008. And compared to that standard, it contains a slightly improved monthly calculation method, and at the same time, it contains a hourly calculation method, but compared to the 13790, this hourly method has been significantly improved. So this hourly method has been tailored to the goal. The input data asked from the end user for the hourly method is the same as for the monthly method, because this was a main requirement from many countries. If they wanted to change to an hourly method, they were afraid that for the end user should deal with more complex input data. Well, that's not the case for this standard. So it's easy for energy performance regulators to switch from the monthly to the hourly calculation. The only thing they have to do is to specify the climatic data, hourly climatic data, once for their country or region, and also the hourly user pattern for the different building categories. But there is a support on these issues, and that support is also growing. Moreover, in many countries, you need already hourly climatic data and hourly user patterns at the background if you have a monthly calculation method, because you need to perform hourly calculations to find the correlation factors and to validate the correlation factors for the monthly method. So, so why would these regulators want to switch? Well, because the thermal balance has become much more dynamic, time varying than in the past. That's also what Jaap showed in his presentation. There's a demand from countries to do this. Coming back to the difference between the hourly method in this new standard 52016 Part 1 and the old one, ISO 13790. In the old one, you saw that all the window elements were combined into one aggregated thermal resistance value. And also all the other elements which had a certain mass, they were all lumped into one thermal resistance and one capacity value to be able to do the calculation with a very simple, simplified method, simplified model. While the input to run this standard were all the individual building elements, the thermal properties, solar properties, and thermal capacity. So what changed with the new standard? In the new standard, all the individual elements remain individual in the calculation. So the input did not change because the input was already per building element, but they are now kept individually, and the calculation is done for a matrix of all these building elements. And this means that you have no longer a loss of information per building element. And that's very important because now you can respect differences in the individual building elements. For instance, the difference between a heavyweight floor and a lightweight roof, which would be in the previous method would be brought together, lumped into one resistance and thermal capacity. So this is much more transparent. So as I said, the standard contains a parallel hourly and a monthly calculation method. So they use the same input data and boundary conditions. Of course, with the hourly calculation, you get also hourly indoor temperatures and heating and cooling loads. You can calculate the sensible and latent heat. And for the monthly calculation, it's much more simplified. You need national correlation factors. The hourly calculation produces also extra output, which are the monthly characteristics, which can be used as a basis for generating or validating the correlation factors for the monthly method. So you can choose the hourly method as your national method, but you can also use the hourly method to generate monthly correlation factors or to compare with a monthly calculation method if you like. This is demonstrated in the spreadsheet on this standard, and an updated version was published at the EPB Center last November. So why was the monthly method so popular in the past? Well, that was because in the past, buildings were different from the buildings nowadays. You had high heat losses, you had comparably low solar and internal heat gains, and then the energy need for heating, this red line, will be the result of the difference between these two. So here you see it illustrated. If you take a mean value, you would have high heat losses, low solar and internal gains, and the energy need for heating would be a big difference between these two quantities. So the high heat losses dominated the thermal balance, and the monthly calculation methods taking these mean values would lead to sufficiently accurate, transparent, and robust results. But looking at buildings today, you see much lower heat losses, and you see that these are now often in comparable size as the solar and internal heat gains. So the solar and internal heat gains are more often even higher than the heat losses as they were in the past. So if you look at the difference between these two, you get the energy need for heating. And if you would take now the mean value, you would have the heat losses and the solar and internal heat gains almost at the same quantity. And the energy need for heating will be just a small difference between these two, and that would be very sensitive for the dynamic interactions and for the actual situation. So the heat losses are low and no longer dominating. Very difficult to find proper and robust correction factors for the monthly calculation method. So due to these increasing number of correction factors that you need for all these dynamic effects, the monthly calculation method becomes less accurate and less transparent and less robust as it was in the past. And you could even see that during one day you would have hourly heating and cooling at the same day. And if you have a monthly method, you would not see that you have the high heating need and high cooling needs, but you would just see a low heating need as the average over the day. So to summarize, the hourly method in the standard can be run with the same input data for the user as needed for the monthly method. It's easier to understand, it's more transparent because it's more direct. There's no need for correlation factors to account for the dynamic interactions, and gives additional insight in the hourly indoor temperature and the heating or cooling load, while the monthly method gives only one monthly average. And it calculates the heating and cooling needs in the same calculation, so you reveal also possible interactions like a nighttime temperature setback could have result in next day and next morning cooling needs. While in the monthly method, there's no interaction between the heating and the cooling needs. The heating needs are calculated for 12 months in succession with conditions which you assume for heating, and then the cooling needs are calculated also for 12 months. No interaction between these two, so it is really an approximation. I like also to mention some new developments. In ISO 5216 part 3 is under development, which is an expansion of the part 1, specifically for adaptive building envelope elements. And then the work just started on a part 5 of the standard, which deals with validation procedures. This standard has the goal to see where the EN ISO 5216 part 1, which has a fully described calculation method, can be opened to alternative calculation models without jeopardizing the reproducibility. And this would bridge the gap to building simulation tools more than it does already. So waiting for the next slide. And last subject of my presentation is that this standard also forms the bridge from the energy needs to the systems, because it can be run in a so-called system-specific mode. That takes into account the impact, for instance, of an undersized heating or cooling power, the impact of recoverable system heat losses on the internal gains, and an imperfect system control. And also vice versa, the output of the energy need calculation can be used, like the indoor temperature and the heating and cooling load, in the system standards as parameters that have an impact on the system performance. So, and if you look at imperfect system control and indoor temperature and comfort, then you see also the link to possible future smart readiness indicator, which could be linked to these kind of outputs from the calculations. So just as to close my presentation, 2 examples of a link with systems. First is the one with ventilative cooling systems. So with the hourly method, you can run a ventilative cooling system with simple transparent rules for the extra ventilation under specific conditions. These rules are directly applied, and in the monthly method you have to introduce a certain monthly mean ventilation rate with a weighting factor that accounts for the number of hours per month that the ventilative cooling system is feasible, and that weighting factor should depend on the building inertia, on the heat balance, on the occupancy rate, and if these values and these functions should be obtained by hourly calculation runs with another model which introduces noise, because it's not always the same as the calculation you're looking for. So to illustrate the simple and transparent rules for the hourly calculation, for the sake of time, I will not read all these details. They are just an example, and you see there are just a few transparent rules which can be debated, can be changed, and then you run the hourly calculation and you get your impact of the ventilative cooling system. And here you see quickly a few examples here with mechanical cooling. Without ventilative cooling, you see here in green the cooling load, hourly cooling load. Here you see the same with ventilative cooling applied. Here with no mechanical cooling, you have a high indoor temperature here. It's about 35 degrees, and it drops to about slightly above 25 degrees with ventilative cooling applied. This is for the months July in office room. And I'll skip this one for the sake of time, more or less similar. And then, so this, here you see the monthly values for the hourly and the monthly method from the ISO 52016, shown from the spreadsheet. Without ventilative cooling system here, the hourly method with ventilative cooling system, so the cooling needs have been dropped. Now you try to do the same for the monthly method, but as I said, you have to just to have a trial and error to find the correct match with the hourly method. So here the match was not found yet. And then finally, on the link with heat pumps, the calculation of energy needs is coupled to the calculation of the heat pump power and performance calculation. And this is just a quick illustration where you have the heating needs very dynamically changing each hour. The heat pump performance also very dynamically changing, also under influence of the heating needs. And the COP, so the performance of the heating system compared to the energy needs for heating, you see there's no simple correlation between these two, and these are obtained from the dynamic link between these two calculations. So the conclusion is that one of the key EPB standards is this 52016 part 1 for heating loads and needs and indoor temperature. It contains both a monthly and hourly calculation method, and the hourly calculation method is tailored to be able to deal with the dynamic interactions between the building climate users and systems, and it requires no more input data from the end user than the monthly method. And this concludes my presentation, and I also are looking forward to questions in the last question and answer section of this webinar. Thank you for your attention.
So, good day, ladies and gentlemen. I'm Laurent Socal, and I'm an independent expert based in Italy. And my task now will be to get you a flavor of the interest in hourly or monthly time step in the technical system calculations. So, just to start from the beginning and just precise the word hourly, monthly, dynamic, which is sometimes confusing. Just remember that the most simple way of calculating the energy performance, that is what happens during a whole year or season, which is a calculation period, is the simplest way is just to make one single calculation using average values of all properties. And the issue is which average value, and Dick Van Dyke already illustrated you the problem in finding the right average value for 1 month in a lot of situations, and how to take into account different operation schedules. So the solution will divide the calculation period into calculation intervals and then repeat the calculation. And the current approach showed is for regulatory purpose, for heating, ventilation, air conditioning, domestic hot water, and comfort services, it's monthly intervals. So we have to classify, and when splitting into calculation intervals, select the calculation or this can be instant, weekly, daily, hourly, or it could be variable, such things, special things like bins, where actually the constant parameter in dividing the calculation period is not the time, but it is another parameter. And usually the most common is outdoor temperature. And then you have to decide if the calculation within each calculation interval is standalone or depends on the result of previous intervals. And we say static when there is no dependency, and dynamic when the calculation in one interval depends on the previous interval's results. And the level of details is another independent story. And for example, the difference between the 52016 and the simulation method, like Energy Plus, could be just in the level of details. Both are hourly and dynamic. And let's continue. Why monthly? So Jaap already illustrated why we are all more or less, most European countries are on the monthly, because historically this was the first attempt of an energy calculation by a calculation interval, EN 832 at that time. That was fine for heating needs, domestic hot water, and technical system at that time were simple, and the main generation technique was a boiler. But how to deal now with cooling need, other services, and this has been described very well by Dick van Dijk. So why hourly? This also has already been illustrated. If you have independent schedule of system, it's difficult to represent by appropriate averages all interactions. And in general, most operating conditions may be considered constant during each hour. So hourly is deemed to be the minimum resolution to describe adequately most operation schedules within a building. And this is the next step in the progress of resolution of energy calculation. And hourly is straightforward to describe the use of a building. But somebody might like also 15 minutes because it's typically used in the power meters for electricity meters from the grid. And however, we'll see that we have some examples where the hourly could be even not enough, not for energy performance calculation, but for other purposes now. So why dynamics? And dynamic calculation is required if you have accumulation of energy or other properties in your building or technical system. Is it appropriate to have dynamics? Well, you have to compare to have this answer. To know if a dynamic calculation will solve your problem, you should compare your time, the calculation interval, with the time constant of your system. What is the time constant? If you have a step in the operating conditions, your system will react more or less this way, which is a typical first order exponential. This is a typical reaction. You slowly approach the new steady state behavior. And the time constant is what happens if you would reach your new regime at the faster rate you have at the very beginning. If your calculation interval is very short, of course, compared to your time constant, your calculation will be probably well accurate. But if your calculation interval is very long compared to the time constant, in that case, you have to introduce some parameters to take into account the dynamics. And that's exactly what happens with the monthly method and all the parameters that were mentioned before to accommodate the fact that with a long calculation interval, you have to take into account something about the dynamics. And the real trouble is when you get into this situation where your calculation interval is quite similar to the time constant. This will be the case of the distribution network, for example, where we have this situation with hourly calculation. And just take an example about dynamics. And if we speak about systems, the most obvious example of accumulation of energy is a domestic hot water store. So it looks like obvious there are dynamics. By definition, you are accumulating energy to decouple the time of use and the time of production. If you do the calculation with eco-labeling data, you will see that the time constant of a heat or water storage is between 40 and 400 hours. So the hourly looks quite appropriate. And with EN 15, 316-5 introduces a dynamic calculation with a 1 hour calculation interval. And let's have a look. The water storage model of this standard divides the storage, into 4 layers. And typically, you have the first layer in the bottom where you will have your solar heater. You have a space for the accumulation of heat from the solar heater, layer where you have your backup heater, and finally the accumulation layer for your backup heater. And then you produce domestic hot water. And the energy balance for each layer will make an energy balance, take into account heat exchange between with the neighboring layers. Actually, this is neglected because it's quite, you assume that there is no mixing in the store, and you take into account, of course, heat transmission towards external and any contribution of heat from the solar or backup heater. Actually, for simplicity, it's not shown here. You can also take into account a heat exchanger, which is taking out energy for heating. And this model is quite fine if it is combined with a solar heating, a solar collector. In fact, your solar collector's energy balance is quite simple. You have solar radiation, some heat is captured. Since you are heating your solar collector, some heat is lost by your collector itself. Then you have your circuit, some heat is lost in the collector loop, and here you finally get to your store. And of course, the losses are depending on the collector loop temperature. If you have a method that calculates hour by hour the temperature in this layer, you may calculate hour by hour the efficiency of your solar collector. And of course, this is quite adequate because within 1 hour, you do not expect that the temperature will change so that you change completely the operating condition. So the alternative is either a monthly calculation where you are just assuming everything is working fine, you take a correlation and get the result, or an hourly calculation where you can really see the effect of the relative sizing of your storage relative to your collectors and the impact also of the use pattern. And you have also another possibility, it is that with time that you can remove one of the assumptions. The monthly calculation assumes everything is working fine at every time. If you have an hourly calculation, you may identify that you are overheating your collector and say, if we reach 90 degrees here, sorry, it's cut off, lockout, and you have to wait until the collector cools down again. And this can be identified with an hourly calculation, not with a monthly calculation that assumes everything is working well. Just the opposite of Murphy law, as you may know. So here is just a slide which is reminding what I already told you, speaking on the picture. So we are removing this hidden assumption, and this may help also sizing and design, knowing that if you reduce the size of the store, you will have a problem of overheating. This is another effect of going to the hourly calculation or dynamic calculation, is that you are converging, you have calculation method converging for design and for energy performance calculation. So the nice thing is that this does not require significant additional input. For this system, you just have to know which is the volume of each layer. This is the only difference from the same data that you will use for the monthly calculation. So this is our result, an example. Here you see the graph, and you see, for example, that here you have in red, this is the heat captured by the collector. In green, which is brought to your domestic hot water store, and this dashed line is the auxiliary energy used by the pump. And you can identify here you have a very sunny day, maybe it's oversized or something else happened, and your pump is stopping here, so you reach lockdown. And here, for example, is a cloudy day, no problem, you are heating your storage all the day long. You can see this also with the graph of temperatures. These are the 4 temperatures of the 4 layers. Here is the bottom layer with cold water coming in, and here you have, of course, in the morning the bottom layer, which is very cold. It heats up, and then all the store is heating. And when you reach here, you are at the lockout because you reach a too high temperature, and then it's cooling down again. And here you have the cloudy day, and nothing happened, everything went well. So you can see all these things on an hourly method, and monthly method cannot identify this kind of issues. Is hourly always okay? So, well, if we speak about the thermal time constant, it looks like it's fine. We've seen this in the previous slides, but there's not only heat, there is also water moving. And in this case, if you are mixing the contents, the time constant is the volume divided by the flow rate. If it is a piston, that means piston, it means that you are assuming the water is slowly going upwards without mixing. And if, of course, if the draw-off volume in one calculation interval exceeds the layer volume, then you have an issue in your calculation. And this is what we have a draw-off in 1 hour, it's okay. But if the draw-off is very high or the store is very small, then you have an issue. That's why, for example, 12831-3, which is dealing with the water storage in a similar way as the energy performance calculation, but for sizing purpose, is using a minute-by-minute calculation so that no draw-off can upset the layer orders. And of course, training all these things to master all these details requires some training and understanding of what you are doing. So this is a possible limitation. And of course, let's have a look at distribution. The distribution system is very tricky, and with the criteria that we introduced before, if we calculate the time constant of a pipe of a heating, ventilation, air conditioning system, typically you are between 0.3 and 6 hours. So an hourly calculation, you are just in an interval which is comparable with your calculation interval and with the time constant. So dynamic effects are significant. And just to give you an example, this is what happens when you are tapping from domestic hot water and you are just filling up the pipe with hot water. You use for probably some minutes, and when you close the tap, the hot water is just cooling down. And this is the effect on a graph with time. And of course, this is not easy to simulate. And if you have to input the average value, you will have this kind of approach. And it's quite difficult to identify this temperature. Maybe you can use another approach, and you know that having this cooling down is like having dissipation or losses at the highest temperature during an entire time constant. And this leads to some calculation methods to be used both for monthly method and for the hourly. So dynamic effects are here not so easy to represent with a calculation method. Another example where the hourly concept is very useful, even without dynamic, is the interaction between photovoltaic and the grid. And the hourly method is appropriate to describe the hourly calculation interval is appropriate to describe the interaction between the building and the grid. Here, no dynamics is needed. And you calculate explicitly the matching. And if you use a battery, in that case, some dynamics has to be included. You can see a lot of details about the impact of hourly or monthly calculation in a series of short videos on EPB Center website. Here you have the link, and you can find them quite easily. And you have videos on exported energy and dealing also with the question of the calculation time step. Just to get a flavor, here you have a simple example. If you are using PV for lighting, of course, you might have needs for lighting, or you use electricity for lighting in the morning, maybe something at midday and something in the evening. Whilst here you have your PV electricity, which is produced during the day. And of course, with an hourly method, you are explicitly checking if the production is matching in time the demand. If you have a monthly calculation, you will need an adjusting factor. Nothing different from the utilization factor of gains that was mentioned by Dick van Dijk in the previous presentation. And a matching factor is a function like this one. Some more details, as I told you in the videos. And the same if you have the connection of a PV with a heat pump, which is very popular. And of course, a monthly calculation method may identify that you need electricity from the heat pump in winter, and you have production of PV in winter, and they do not match. But there is more to say, because you have also the problem of The PV is during the day and producing during the day, and the heat pump probably is running during the night as well. And so hourly calculation will get all these kind of things without any need of a matching factor. Other subsystem of technical systems of heating and domestic hot water. In general, there is no significant dynamic effect for boilers, cogeneration unit, heat pumps, space heating, and control. I mean dynamics within the same calculation method may be used for monthly and hourly calculation. The problem is the generator sequence. What is difficult to catch with the monthly method is tricky to identify the part of load left to a backup generation device. And there again, you need a statistical factor. The turnaround could be used a bin method, for example, for the generation. And this is done, for example, in Italy on a monthly basis to explore the combination of a heat pump with a boiler. So the solution, of course, is hourly method identifies the load to the backup heater hour by hour very easily. And you might have the reverse problem is fails alarms. I mean, for example, your heat pump, which is doing domestic hot water and heating. Unfortunately, in that hour, you have the store asking for domestic hot water, for heating, and you might use most of the time for domestic hot water, and it looks like you're not able to provide heating. And this is a little bit tricky, and it has to be solved to avoid a false alarm during the calculation. This is one of the example of things that has to be improved. You heard about some proposal from or being worked out in Italy, and this is one example. Ventilation and dynamics, and here, for example, with ventilation system, time constant accumulation of energy within the ventilation system, that's completely negligible. What is not negligible very often is the accumulation of humid air, CO2, and other pollution within the building volume. This is an example, is a graph. It's my own house, and you see that in the night, 3% in the house, the CO2 is increasing, and then in the morning, everybody goes to work and to the school, so the CO2 is decreasing, and then somebody comes back home. That's my son studying, not so much, then going to the training, and then we're all back. But that's to show the importance of dynamics, and an hourly calculation can catch this trend and take this into account in the performance of your systems. And this is an example instead of ventilation and hourly. Please remember, hourly is not the same as dynamic. And for example, air treatment requires a lot of energy, also for dehumidification in the Mediterranean climate. And conditions are varying along the day and may be influenced by accumulation in the condition space. This was a previous concept of a previous slide. The usual design routine, you calculate the air treatment in one design condition. The new EN standards are able to calculate air treatment for all hours. So you just describe the building and system only once. So you have these schematics, and you have the options to describe your technical system. And that's not peanuts, because you can see here, these are resulting graphs, and you have the graph is constructed half 24 hours is a winter day, and the second half is a summer day, typical. And you have, for example, here, just have a look at the scale. Here is your heating coil input. You see here 6,000 kilowatt hours, and you see here for cooling 25,000 kilowatt hours. So 4 times more for cooling and dehumidification. And without the heat recovery, you would have a very high energy use. All this calculation done hour by hour. That's another perspective in designing, and it's useful information as well for the design. All these graphs are taken from the example spreadsheet you can find on the EPB Center website in the section documentation. And this here is another aspect. This has been already mentioned by Dick Van Dijk. Is a interaction between the building and the systems. And the fact is, for example, that here you have occupancy. It starts here, and probably you want comfort. And since now we are able to calculate the evaluation of internal temperature, we know that we start our system operation here. We might not reach the set point in due time when occupancy starts. So you might have two issues or two opportunities that's calculating or showing the optimization. It means having the right time of the right anticipation of system operation, and you might also calculate the possible discomfort in terms of degree days or whichever other indicator that means you were late in reaching your set point. Also to prevent that this becomes an advantage for poor systems. Of course, with an hourly method, you can identify this. On a monthly method, you have no clue about this. You have to introduce a parameter that will tell you directly the effect of this without any calculation. That's a priori. Input data. This also has been told a lot of times. I will not repeat a lot. I will not repeat everything. The important thing is that for the standard use, for the user, there is no or quite little difference. If you are selecting a space category, this determines the whole standard use profile, no additional effort for the standard user. As well as when you select the location, you either select 12 monthly method or 12 monthly values of external temperature of the whole yearly profile. For a custom application, you might complicate the input, but that's just for energy audit or for specific application. You might even use this for design using a stress profile, for example, iterating on a peak day or a peak week to see if your system is matching the load. And you need perhaps some more details about description of products to include some dynamic parameter or the volume of each layer, for example, the store. But really, that's little things. And the description of building elements and geometry is quite the same. So as a summary, we can say that the hourly method allows to describe in a straightforward manner the use of complex building. It's easier to take into account interaction between multiple technical systems. Dynamics allow to take into account accumulation of energy in the building envelope and in the technical systems. Hourly and dynamics is no or quite low extra effort on standard user input. It's a natural progression of calculation techniques and required to consider the indoor environment in more details. We are much more concerned now with indoor environments. And at the end, it will allow conversion of energy performance and sizing calculation, possibly with the help of some sub-hourly calculation. Thank you for the attention. And this ends my presentation. And we are available for questions.
Thank you to all of you for your presentation. So yeah, we can start the Q&A with the first question. Should the national annexes be reported to the European Commission or to whom? And if so, will they be made publicly available?
Well, perhaps I could answer this question. Yes, the national annexes should be reported to the Commission. They could be national annexes, as you call them, when they are published by the National Standard Committee, the National Standard Organization, or they could be national data sheets when they are part of the National Building Regulation. In both cases, they have to be reported to the Commission. Do they become public? Well, if they are part of the national legislation, they are public. If they are published by the national standard body, they become public. But then they will be published by the national standard body, or they will be published in the framework of the national regulation. It may be the case that the versions that are now reported to the Commission are not public yet, because they are not already in the public domain in the national standard body. They are still in an inquiry stage, or at the national legislation level, they are still under debate. but that's a matter of time. Thank you.
Thank you. So a second question. There appears to be strong push towards hourly methods. Why are the overarching standards updated relatively recently still allowing monthly calculation if they aren't the desired approach?
Perhaps Dick, you could answer that.
Yeah, so the question is whether why the overarching standard still allows a monthly calculation method. Is that the question?
Yes, so I understand. Yeah.
Okay, so yeah, well, as was explained in the presentation by Laurent and also by myself, the monthly calculation method has been very popular over many years, and it would be too much of a sudden change to only advocate the hourly calculation method. So countries need time to change to an hourly method, and it also depends on the ambition level of a country, whether they like to also to have a simplified method, maybe for a simplified application. Could also be the case that you have the monthly method only for simpler cases. And we heard already also today that one of the bottlenecks is that there is a need for a software tool, a common European core perhaps, for a software tool that would make the change over to an hourly method more easy. That concludes my answer.
Yeah. Sorry, I was waiting if someone else would like to add something. So let's go on. How do these standards deal with allowing a more dynamic indoor temperature? For example, users being accepting of a wider range, for example, 1826 degrees, and only partial heating of indoor volumes, for example, the living room. Maybe it's for Dick.
Yeah, I think I can answer that question. I'll try. So with the EPB standards, you try to assess the performance of the building and not the user. So the first part of my answer is that you need a standard user profile for each building category that you identify in your country, and then you compare the calculations with these standard user profiles. Having said that, there's a complication, and probably the questioner refers to that, is that in a building you might expect to have a heating system in all the spaces which are occupied for living or for working, and then there might be spaces that actually don't have a system, or the system there could be a system but could be heavily undersized. So what to do then? And for that case, the standards clearly indicate, that's in the overarching standard and also in the post-processing standards, that you have a choice to consider the rooms for standard conditions, which means that if there is no system to give you to reach the required temperature, then you assume a system and you run your calculation as such with the assumed system with a default efficiency. Another approach is that you identify these rooms that have not an efficient equipment, and then you see specifically, if you use an hourly calculation method, that the actual temperatures are not according to the expected comfort levels, and you report separately that the thermal comfort in this case is lower than you would expect, and lower if you compare it with other buildings which have a properly sized equipment. And that,
And
yeah.
perhaps to add to this a question, how does this relate to the concept of asset rating? Because the rating you declare in your energy label is based on standardized occupancy pattern. So if you want to compare one building to the other building, you want to compare it under the same conditions. How to deal with that? Dick, will you
Yes,
continue?
therefore you have therefore you have these two choices. I would say that you say,
Yeah.
well, no, either you assume a system that's properly sized, and you do the calculation with that to get your asset rating, or you get a more beneficial energy performance because the system cannot cope with the required heat, and then you report separately the discomfort that you have, and that's up to national level to make the choice at this moment.
But perhaps the second option is more related to energy auditing, to say, okay, what to do to make the building more energy efficient. If you don't use a part of the building under the indoor environment that is normally required, you come with other advices. Yeah.
That's absolutely true, but it's also very important if you want to compare buildings that you know that they have a level playing ground in the assessment, and therefore my first answer applies.
Yep.
Great. So I move with another question. What is the common practice in the European countries? Which organizations are doing national annexes? Standard institutions, governments, private companies? Where the funding requirements, decision or initiatives come from?
Well, I can answer maybe for Italy, but I think it's not that different in other countries. This is dealt by the ordinary standardization institutes, because in any case, if you EN standards, you have just to prepare the annexes. If you have your own national standard, you have to prepare the whole standard. So typically, it is the same people that were involved in the national standardization organizations that now are participating into the European or even ISO standardization, and at home they for the application of the standard in their country, at least I guess by public authority if they want to have this in their regulation, if we speak about regulatory purpose.
Someone
Yes,
wants to
I
add?
think this is correct. It will be similar in most European countries. I think the priming partner is the national standardization body, and they should take care of it, of course, in cooperation with their national focus groups, as you do with national standards as well. And there should be a strong relation between the national focus groups who work on also mirroring the normal European standards, and of course also with people who are responsible for the building regulations. But it should be preferable the responsibility of the national standard body.
Okay, I'll move on. For the Howley method, does it mean that large national databases of inputs need to be developed for all input items so that the appropriate defaults were used for Howley calculation?
I can start giving an answer to that. So what you need for the hourly calculation is the hourly boundary conditions, which means the climatic data and hourly patterns for the user. Well, the hourly patterns for the user do not require a extensive database that could be tabulated. For instance, in EN 16798 part 1, you find in an annex these kind of for default use, these kind of user patterns. For the climatic data, you indeed need a database with the hourly values.
Yeah, well, what can be added also is maybe, as you already told, it's not necessary that you have 8,760 values for each input parameter. A lot of parameters are fixed, and even the occupancy, for example, you just define what happens in 24 hours of a working day, 24 hours of a holiday, and maybe 24 hours on a Saturday, and you have this pattern replicating all the year long. So sometimes it looks like there is a lot of data, but a lot of things are repetitive or indeed constant.
Yes, and perhaps to add to that, there are some questions from countries that have very different climates and regions, well, like Italy, but also other countries. And these databases are at this moment not always available. I know that the Joint Research Center of the European Commission is working on making those hourly databases available for different regions, and that could help those countries who don't have a very detailed information about their methodological data in their country.
Thank you. Another question. Is it possible to use the evaluation of energy needs to design a humidification and dehumidification? How different are the parameters of ISO 52016 from the carrier method?
I might have an answer, even though I'm not the specialist of this precise field. Very often you can extract useful data for design from the energy performance calculation. For example, for sizing a heat pump, you can plot you can plot the required power against external temperature, and you have something based on the energy instead of a bare heat load that will oversize bluntly or terribly your sizing. For the carrier method, as far as I remember, it is a method that starts from the response to an impulse. You have accumulation factors that are a typical response when you have a unitary contribution from gains or other types of loads. And of course, these accumulation factors were derived for standardized conditions, that is, for average or special conditions. When you're calculating 52016, you are calculating the response of your building and your system with this specific configuration. So this could be beneficial to avoid oversizing. Every time you are using something that is average or not specific, you will oversize for to be safe that you reach the objective. Not know if my colleagues have something else to add.
No, that's well described.
Okay. Okay. Would you like to add something?
Yeah. By the way, I think this is another idea that has to be well known. The energy performance calculation is an extraordinary source of information for the design. You just need to go a little bit further than just the standard calculation. It reminds me when you look at an offer, and very often your customer just look at the final figure at the end and doesn't look at the rest. And that's a similar when you do an energy performance calculation, you see the energy performance, but there are a lot of information in the middle that is very useful.
But
Okay,
for design, you would probably tune your conditions to the design conditions, and also tune the space to the spaces which are the most sensitive.
Of course, and what is interesting and is that you have the same description of the building for the two things.
Yeah.
Just the design and the energy performance calculation. That's a great advantage, for example.
Yeah, that's also the reason why a few years ago in the ISO 52016 Part 1, the calculation of the design cooling load was integrated. So you can do that calculation. I didn't mention it in my presentation, but you can do that calculation as an integrated part of the 52016 Part 1. So you use the same input data, but just change the input data which are needed for the design conditions.
Okay, so unfortunately I have to close our Q&A session. I apologize for not reading all the questions. So if someone wants to ask this question directly to the panelists, please do so. And so thank you to all our panelists for today and for the people who attended. And hopefully we'll see you next time for the next webinar on the 16th of June. Thank you.